Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Logical Time and Global State. Today we are going to discuss about Global State Snapshot Recording Algorithm, Introductions, and system model and definitions, then snapshot algorithm for FIFO channels. Introduction. A distributed computing system consists of the processes that do not share a common memory and communicate asynchronously with each other by message passing. Each component has a local state. The state of the process is the local memory and a history of its activity. If the shared memory were available, an up-to-date state of a particular end system would be available to the processes sharing the memory. The system model. The system model consists of collection of n processes P1 to Pn that are connected by a channel. There are no globally shared memory and physical global clock, and processes communicate by passing messages through communication channels. CAG denotes a channel from process PI to process PJ, and its states is denoted by SGI. The actions performed by a process or model, there are three types of events. First one is an internal event, then second one is a message send event, then third one is a message receive event. For a message MIJ that is sent by process PI to process PJ, let send of MIJ and receive of MIJ denotes its send and receive event. Consistent global state. The global state of a distributed system is a collection of local states of the process and the channels. The global state is given by GS equal to union of all local states. There are two conditions. First condition preserves the law of conservation of messages. Then second condition states that in the collected global state for every effect, its cause must be present. Interpretation of cuts. A cut in a space-time diagram is a line joining an arbitrary point on each process line that slices the space diagram into a past and future. A consistent global state corresponds to a cut in which every message received in the past of the cut was sent in the past of that cut. Such a cut is known as consistent cut. In a consistent snapshot, all the recorded local states of the process are concurrent. That is, the recorded local state of no process causally affects the recorded local state of any other process. Issues in a recording a global state. The following two issues need to be addressed. First issue is how to distinguish between the messages to be recorded in the snapshot from those not to be recorded. First, any message that is sent by a process before recording its snapshot must be recorded in the global snapshot from condition 1. Then, any message that is sent by a process after recording its snapshot must not be recorded in the global snapshot from condition 2. How to determine the instance when a process takes its snapshot? A process PJ must record its snapshot before processing a message MIJ that was sent by a process PI after recording its snapshot. Next one is the Chanty-Lamport algorithm. This algorithm is used for the Chanty-Lamport algorithm is used for the synchronous. Here marker sending rules for process. Then after that process I records its states. Then after that for each outgoing channel C on which the marker has not been sent. I sends the marker along with them. See, before I send further messages along. See, marker receiving rule for process J on receiving a marker along channel C. If J has not recorded its states, then record the state of C as the empty state. Follow the marker sending rule, else record the state of the C at the set of messages received along C after J state was recorded and before. Then next one is the correctness and complexity of the particular algorithm. The correctness is due to the FIFO property of channel. Due to the FIFO property of the channel, it follows that no message sent after the marker on the channel, that is recorded into the channel state. Thus, the condition C2 is satisfied. When the process PJ receives a message MIJ, that proceeds a marker on the channel CIJ and it acts as follows. If the project PJ has not taken its snapshot yet, then it includes a MIJ in its recorded snapshot. Otherwise, it records MIJ in the state of the channel CIJ. That is thus condition C1 is satisfied. The complexity of the recording part of the single instance of the algorithm requires order of E. That means order of T time. E is the number of edges in the network and D is the diameter of the particular network. The Chanty-Lampard algorithm is mainly used for the snapshot algorithm in FIFO channel. Then the properties of the recorded global state. The recorded global state may not correspond to any of the global state that occurred during the computation. This happens because a process can change its states asynchronously before the marker is sent or received by the other sites, and the other sites record their states. But the system could have passed through the recorded global states in some equivalent executions. The recorded global state is a valid state, is in equivalent execution, and if a stable property holds in the system before the snapshot algorithm begins, it holds in the recorded global snap. Therefore, a recorded global state is useful in detecting the stable properties. Thank you.